All right, team, here we are again. We are up on another TPO roof. It's got some pretty clear damage, but TPO is not always the easiest membrane to find hail on. So I'll show you around and let's see what we're looking at. So we got engineering firm, we got part of the insured side of the adjusting team, we got part of the insurance side of the adjusting team, a consultant, engineer, HVAC engineer, ownership side of the adjusting team, someone to represent them, make sure they're not getting mistreated. Well, you don't see that every day. Anyway, so you can kind of see what would look like a pretty big splatter, but first things first is looking at ACs. This one's just way too obvious. That is a massive amount of hail. Obviously the hail is going sort of this direction, but perhaps across. You can see on our 24 gauge steel some pretty good dings. It's a heavy metal that should not ding very easily, kind of like the steel that's on these AC units. That steel is not going to get a ding in it. But now we need to look at the roof, and so engineer team over here, he's marked out a square, which I gotta say is not really it's not normal in TPO to mark a square and look for a number of hits, but he is finding indentions, and then we will cut the roof open and we'll figure out exactly what's going on. So there's a very interesting indention right here that I would like to check out, but we'll go within the square that he marked and kind of see. He's got it marked out 10 by 10, and anyway, everybody's doing their job. Everybody's looking for evidence of hail. So here's the reverse. So let me zoom in just a little bit there. You can see an AC that's just completely beat up, and then now here's one from this angle. It's not that bad. Looks like we probably had multiple storms here. So here's one, some evidence at an angle that is not consistent with the heavy hail damage. So I'm sure they've had multiple storms come through here. So that's just a caulking, and we're not going to worry about that. That's not what hail is going to look like on a TPO roof. Hail, you're going to see and feel an indention, and you need to cut it open. If you can see a fracture, hey, that's great. I will look for some. And anyway, if you see a fracture, great, go there, look at that, cut it open. Have the ability to patch TPO. Do not just go cutting open TPO roofs. You need to weld a patch back on there, but cut it open, see if you can feel on the backside, see if the membrane is split on the back, or also the ISO board that's underneath it, because 99 out of 100 times you're going to have ISO board underneath TPO, and see if that broke at all or is at least indented. And if everything is consistent, you really don't need to find a certain number of hits per square. So anyway, there they are marking. You can see you're marking up everything metal that's just clear and obvious. And the roof has good drainage, but this is why we sink our drains down. We taper down around the drains so that we don't have big water puddles that grow trees in them there. Kind of like this one is. That's perfect. You just want it sunk down. So you got crickets. You got this whole roof, or half the roof sloping this way, half of it sloping that way. And the roof that's sloping this way, it's got a cricket in between. You can see the watermarks carrying water to each drain, and then you want to sink that drain down. And yes, every once in a while you probably want to come up and clean them out. You can see accumulation that's causing water to pool up there, but that's how a drain should be, not like that last one. These are called overflow scuppers, but I would not put them on the high side, ever put them on the high side of the cricket. So again, you got a cricket that starts here and goes to that drain, comes here, goes that way, right? So it's built like a triangle. why in the world would you have your overflow scupper on the high side of a cricket? This roof is going to cave in way before it ever gets out that. So the overflow scuppers are for stopped up drains. You got all your drains stopped up, water's got nowhere to go. This is an indicator that, hey, oh, we got some problems up there. But when your scupper is so high that this roof would be flooded with 6 inches of water before it ever got to it, your roof's going to cave in long before that. So I don't know who designed this and what they were thinking, but that overflow should be right behind that drain, a few inches higher than the drain. That's it. It's simple. And there's a reason that it's built that way. You want to know when drains are stopped up. You're not on your roof every day, and you need something to carry water out when your drains are stopped up. It's a pretty simple concept. It's kind of goofy deal there, but I'm not worried about it. Anyway, so I will follow up when we cut up in the roof. I'll do a little follow up and show you what we're cutting, why, but everybody's doing their investigation right now. And you can see the HVAC engineer going over stuff, and then we have the roof side engineers going over everything on the roof. And this is pretty funny. You definitely don't see this every day. You got 2 turbines here. Those are residential slope roof turbines that are up here. There's easier ways to vent a roof with a correct way to patch those in with joints that don't leak. You know, the whole apparatus is not made to be on a flat roof. So obviously when we re-roof this one, which I can pretty much tell you right now is going to get re-roofed, we'll change those out, make sure all the insulation's up to code. Currently we're in Richardson, Texas, and they're still using 2018 IECC, that's International Energy Codes. And we need 4.4 or 4.5, depending on whose ISO board you're using, and 4.5 inches of ISO. And ISO being polyisocyuronate, still the best insulator on the market, in most people's opinion. And that's definitely what we use. So anyway, here's a TPO roof. If you're not familiar with it, these are pitch pans. Obviously that name coming from back when pitch tar was the most popular flat roof product. That's kind of goofy deal there. Must be something wrong with that pipe jack, or we call them witches hats, but anyway, it's just a pre-made pipe fitting for PVC pipes and whatnot. But these pitch pans, obviously something doesn't match here. These are a pretty universal brand of products there that are, just depending on manufacturer, what, a lot of Firestone is going to say Firestone on it. Anyway, here's a good example of a scupper. This is classic, just perfect example of a scupper. How you flash that in, you can see all along the cut edge, you can see a cut edge sealant. This must be a factory edge because you don't see any cut edge sealant on it. Perfect example of a scupper. That'll pass inspection every single time. Then here's an example of a drain that's just needs to be taken off, brushed off. You can just snap these off. You just turn them and get them off. Anyway, just clear all that off. I mean, you're really talking about once every, and this has a lot of trees around it, but like once every 6 months you get up here with a blower and keep your drains clean. It's not much to it. Again, scuppers are too high. Water may actually be getting to this one because of how stopped up these are. And here's somebody's broom head that they have tried to clean this. They tried to clean it off before, but you actually got to scoop that up and get it off the roof. Anyway, I'll follow up with another video of when we're cutting the roof open and go from there. Stay blessed.